So far yesterday, what we have seen that if we have to think about, let's say, a YouTube or any of the system, we thought about the high level requirement of the whole system. What are the things would be required as in a component, right? And for system design, what are the things that you guys need to read about it? So that are the few things, and few of the things I have explained you that in this way, this topic will be useful. So few of the things that we discussed so far. Let's get started with, as I said yesterday, that we need to think about systems. So when you're uploading a video to YouTube, we thought about user management, uploading system. We are just uploading a video. Now, a system or a services, bunch of services or anything, which just takes care of uploading a video. And why so? From your browser, the video will be uploaded in chunks, because let's say you're uploading a video of 5 GB or 4 GB or 1 GB or something. The whole data of 1 GB will not go through network together. So that network layer processing will happen from your side as well. Encryption, decryption, and everything will happen at your side as well. That has to be handled at your system. That is first thing. Second thing is that if you want to do some other processing of that, as I said, that let's say you are checking for security, that because these are the network bits. So if the bits are coming, whatever the number of content is coming, that content is how much legal, how much illegal, does it contain any abusive words or pictures and all that thing. So if everything you want to process, right? So that processing you'll have to do in a different system itself, right? And let's say query system means you just want to view the video. So these are the few basic components that we could think of initially. And then we thought of the security. As I said, when you are uploading a video, obviously it can have some malicious content in textual format or JavaScript. As I said, it can be XSS attack, or it could have been SQL injection and all that thing. So you need to have, for before all the system, before your what we can say query, before your request, or before your request hits to any of the server, it should go through a security system. Okay. Post that, what other system we could think about it? So I'm asking you guys, let's say this question is asked to you. What do you think? Okay, these are the few systems you guys have thought. What other thoughts or what other things you can think about this question?
A distributed cache.
Okay, so cache will come. I think yesterday we discussed that cache will have to be present when before hitting a DB, you want to give some data directly to the output, right? So there can be a cache, which I think previously also we have taken, which can be associated with server or without server as well, right? So that kind of cache system we already talked about in, yeah, over here, in process cache or distributed cache, something like that, or single cache. Such kind of mechanisms, multiple mechanisms you can think of when you have to think about the cache. So apart from that,
CDA.
so all that things which is covered, that I'm not incorporating, because in that way your diagram will be huge. So right now we are just going for a smaller things. Let's think about just in terms of system, the way we have thought about one system, second system, third system, any other system we can think of. Or let's say just discuss or just think about that, what kind of work or what kind of subsystems your upload system will have, or what kind of subsystems your user management or query system will have, what kind of work it will do. Sorry?
Encoding means before uploading we need to have different formats.
Exactly.
Encoding.
Let's say one of the tasks is encoding. So encoding and all that things can be a separate system. Decoding, that can be a part of query system. Anything else?
For user management, you can have authorization, authentication.
Authorization, authentication, and some of the services like change password and all that things, details related services. right?
Yeah.
Set of services. Now in upload system, can you keep a duplicate check? And as I said, it's just not a simple video checking of the that whether this video is already been uploaded by some other user or not. It can be, as I said, that chunk, let's say, because one video can be in chunks of many videos. So let's say one video is there which is of 1 GB, and you are storing it in few chunks, and somewhere you have kept a map that, let's say, video ABC has the chunks of A, P, Q, and R in the same order. Let's say A, P, Q, R, and S. Now the benefit of this would be, let's say some other user uploaded the same video with extra chunks. Extra chunks in the sense in between he has added some advertisements or something like that, such that both the videos checksum are not same. But at the end, let's say there is some X, there is some A, there is some B, there is some P, there is some Q, there is some R, there is some S, and at the end some other things. So in this case also, video is duplicate. So you need to have a strong system which checks whether the video is already duplicate or not. Correct? And rest of the things also, yesterday we discussed that you need to have piracy check as well, right? That whether this video is pirated or not. Abuse check should also be there. That does this video have some kind of abusive content or not, right? So many things, or so many services, I would say now, would be associated with upload system, and they could be like this. As I say, duplicate check could be there, piracy check could be there, editor service. You want to edit the video afterwards. You want to add, let's say I'm uploading a video and I want to add the logo of Go Ahead afterwards, or I want to edit the video, something like I want to change the size of the video, or I want to trim the video, something like that. If I want to do, I can do right now in YouTube, I can do. So such kind of services should be there. So now from the system, we are thinking about all those different services. Abuse check should be there, right? So these are the few work or the few services which can be incorporated with upload system. With a query system, again, there can be multiple. As I said, you want to run some advertisement when you are giving the views to a person. What else can be there with a query system? Query in the sense you are viewing, you want to request, or you are requesting to view some video.
If you, okay, view as in you already know which video, you're just clicking on it, is it?
Yeah, exactly.
Okay.
So let's say I'm clicking on a video, I'm requesting to DB that, okay, give me this database or give me this video. Now that system, that is the primary work of this system. But along with that, what other kind of services it will incorporate in itself, which is like, consider it as the monolithic system whose work is just associated with giving the content to a user, that's it. But along with that, what other kind of work it will do, right? That will be its services. That is what I'm telling you. So what other work this system will do? As I said, one can be advertisement services. So it will check if let's say if this video has been uploaded by a user and he is monetizing the video, so let's add the advertisement in between, right? So the advertisement service will come. So before user requests and before it gets response, it will query the advertisement system, checks should we add, create the content back, and then it will return to user, right? Then you will have the video uploaded and started. So this is one of the work. Any other work you can think of?
Like social media stuff, like comments, number of views.
Exactly. So what it will be, let's say, let's consider it as something else. Consider that activity. Whatever the person is doing activity on this video, that will be also stored via the same, because the same thing, because whenever the video will come, to a person to view. Along with that, number of likes, number of dislikes, number of comments, everything will come along with that. So you are also discussing with the activity that along with this video, what are the activities are associated? Anything else?
Loading related videos as well. Is that the same?
Exactly. You can think about recommendation as well, right? Because you will not just return a video. You'll also, if you have seen in YouTube, there are some of the recommended videos come which are similar to this in terms of tags, in terms of your user history. So now you think that user management system, upload system, sorry, query system will discuss with user management systems one of the services, which is like user's history. And from the user's history, it will fetch, it will bring back the data, and it will give to recommendation system that user has in past have seen some of the videos, and associated with this video there are few of the videos. Whatever the intersection of this recommendation service will return to query system, and query system will give it back to user, right? So now you are thinking that, okay, what kind of services this guy will contact to this guy. So this whole thing will come into the architecture high level design discussion, and we are just going one by one, adding the components into that. So now we thought about the recommendation system. Anything else? Let's say first time I'm opening the YouTube, what content should I get? That also should be the part of query system. I'm not opening any video, I'm just opening a normal youtube.com. So that is also a retrieving system, query system. So what about the default view? What should be my default view? That also should be coming if I'm not querying anything else. Correct? Now, along with that, if there are, let's say, live videos or something else, let's say trending videos and all that things, you are monitoring the activity. I won't say just the activity of a user, but the activity on this video, that how much likes it is getting, if it is should be in trending or not, hashtag one, it is coming like in this region, is it coming as a rank one or not, in this country has it been trending or not. So that monitoring also you will keep on tracking. Correct. So there are few of the system which will be associated with that, because the person views this video, that means one view has been added, so it will fed this data to monitoring system as well, that hey, this video has been added or read once time, the same video has been read by many people, then obviously monitoring system will give its ranking to a higher thing. So point is, such kind of subsystems one larger system will have. You can consider that each of them as a services. Anything else currently, let's say, we can think of? Let's say, okay, this would be enough. Default view system, activity, monitoring, and recommendation system. These are a few of the systems or services we can think of.
You can have the publisher system as well, right? The system that whoever, like, actually you are doing the publishing. Sorry, it is already included, I think. Yeah.
Now let's think about, so far we have thought about the components, that which kind of components, which kind of service we can have that. Now let's think about DB. What kind of DB we will have? How can we do the scaling? Now we'll discuss about the DB. DB's scaling, DB's design, and rest of the things, that which kind of things you should have it along with this thing in YouTube. So what are your recommendations? So first, let's think about it. What type of DB should I use? That is my first point.
High read.
Okay. Second.
I don't know. What is the advantage and disadvantage of SQL and NO-SQL? I think NO-SQL is better. So
it should be available. So you should have designed a DB system. We are not discussing about the DB tables and all that things.
Okay, fine.
Just the DB thing. That also we will discuss. I'm not telling you that we will not, but
do we need indexing for this? Like
yes, why not?
Yeah,
so indexing will be, obviously it is part of both. SQL and NoSQL.
Yeah, so Elasticsearch or something.
Yeah, so that will be like Elasticsearch will be like caching system, right?
Okay, fine.
Hmm.
Uh,
So few things that we know that first thing, it should be distributed. Why? Because some of the trending videos in US will not have the trending videos in India. So region wise, probably I will have to distribute my DB. But at the same time, they all should be connected. It's not like that, though some some video uploaded which have been the part of US system, they are not being viewed in other systems. So the availability of the each and every video should be across each and every distributed DB, but the primary content will be based upon the region. Let's say that video have been uploaded like Gangnam Style, right? So that would have been majorly into Southeast Asia, but not into Europe, probably, right? So in that way, you may have to distribute your DB. So which kind of DB now will be useful for this? SQL or NoSQL? First of all, let's think about it. Which kind of, now as I know which kind of subsystems I need or the requirements I have, what thing will be necessary for me? So first, let's discuss about it. What are the benefits of SQL?
it's very stringent, as in it's very tightly, how is it? Strongly, like you can force the columns and they won't change unless you do certain commands, like on the table. Whereas on Mongo and NoSQL, you don't have to force the schema. You can
So
add as many columns as you want in any record.
so it's like unstructured and structured data,
Unstructured and unstructured. That's the word.
right? So if you want to add some extra columns in SQL, it will be tedious task because you have to add that column into each and every record. Over here, it's not necessary. It can be flexible. So structured data. Okay. Anything else? The difference or the main usages of if
So NoSQL is very high read,
Mhm.
and SQL is probably slower than.
You cannot say like that. So
No,
far,
okay,
so far, all the systems were on SQL only.
okay. But then, okay, I don't know. Somehow I read SQL.
Mhm.
Some of the SQL stuff is quite slow compared to NoSQL.
Okay.
Okay.
So if you want to just like think in this way, that
Double,
yeah, yeah, Anurag,
we can do complex queries on SQL database.
exactly. Joins are easy over here, right? Over here, joins is not easy. Transaction can be managed over here, correct? Transaction cannot be managed over here. So the ACID property, which I say, it is proper. It can be handled over here. It cannot be handled over here. Correct?
Yeah.
Anything else?
Why so NoSQL does not support database transactions?
Transactions, you cannot create transaction into that.
Okay, fine.
This transaction in the sense you want to roll back some of the transaction.
Yeah,
That
yeah,
kind
yeah.
of thing. Asset property, well, atomicity, if you want to keep of 4 different kind of things, you cannot. Now, along with that transaction and ACID property, atomicity, I have one more discussion also, that how will you handle ACID property into microservices? Can you? Yesterday we discussed so many things regarding microservices, but this is also one of the point we haven't discussed about it. It's a good point, but we'll discuss it later. So transaction you can handle with the SQL, NoSQL, no. When you read about SQL and NoSQL and all that things, probably one of the major which people have said that the major distribution or the major difference between both is its scaling. SQL is vertically scalable, and NoSQL is horizontally scalable. Now tell me, which one will you prefer for YouTube? Obviously, you can have so many things like ETL. You can have SQL if you want, right?
I would prefer NoSQL because
Okay.
there's no need for strong joins or something, and it's easier to search, and it's easier to add new columns or new so like properties to a document, and it's distributed as well. So
Mhm.
that way, I think, and there I don't think there is a need for transactions in
Mhm.
the video upload or video watching thing, unless it's a bank. You don't really need. That's one of the examples. But
Mhm.
I think if it was YouTube, I wouldn't worry about transactions as much.
Mhm.
Um,
Okay.
what-
Anurag raised a hand. Let's hear Anurag. Anurag.
Uh, we can use combination of SQL and NoSQL. Why? Because NoSQL can be used for storing the data of videos, and SQL can be means the SQL can be used for storing the user name and user related data. Why?
Okay.
Because those things won't be changing. But with respect to videos, we can have means we need to have some horizontal scaling. That is what I.
Exactly. So I won't say in terms of scaling, but I would say in terms of parameters. The columns can be changed for a video. So initially when the video started, YouTube started, there was no hashtag kind of a thing. There were no tagging system like this video has been tagged with few of these subjects. That kind of systems were not there. Now it has come along with that. So probably for that kind of structure, NoSQL is better, right? And as you said, for user related some data whose structure will not change much, for that this thing SQL is useful. Makes sense. Elasticsearch for searching and caching as well, both the things can be applicable. Elasticsearch is in a third party component which can be applied on SQL and NoSQL as well. So searching would be easy in that terms. Exactly. Now when you have to associate user related payment, then when the payment comes, who raised this point?
that was me. That's
Yeah,
when you need transaction.
that's what also Karthik suggested, that at that time you need the transaction. Now the videos can be paid as well, right? In YouTube, videos can be paid as well. Now how you will handle that? That is second thing. So now in YouTube videos, you are storing in NoSQL. Now there also the paid and unpaid system and all the things are coming up. That's second thing. Now let me ask third thing. How will you store the video? So let's say you have a video of 1 GB. Where will you store and how will you store?
Like on the file system or as a blob, you mean?
Exactly. I was asking the same thing. Will you store it as in a file system or you'll store as in a blob or glob? Blob only, probably. So blob will be for SQL, and file system also you can have in the SQL. Blob probably there no possibility of in NoSQL, but only file system you can have in NoSQL.
I think file is the best thing. Blobs are a bit of a hassle. Um,
Mm-hmm. Yeah,
uh, and file system is valid for both the databases, so you can, whatever you decide, it will work with
just
both.
like S3, right? You have a
Right.
system in which you upload a content and you'll have the URL to access that, and you'll just store
Yeah,
that URL into either the
yeah,
table over here or the NoSQL table. That
yeah,
with this URL it is accessible.
yeah. File is the best, and you can do, like, you can reduce the size. You can do whatever as long as it's in the file system. With blob, I don't think you have many options.
Mhm.
Then what was the question before this? You said how would you handle the payments, right? Like How would you
matlab,
actually?
like there'll be a paid videos as well, and users are also paid. They are buying the subscription. So
Yeah, so that way you can have, that's where you can have SQL. I think how Anurag said before,
Mhm,
you can have a combination of like a database that can support transactions,
mhm,
and wherever you need that support, you can talk to SQL, sorry, yeah, a SQL based database.
mhm,
And wherever you don't need, you can use NoSQL.
mhm. Then what about scaling? So you have some of the things which with these equals. If you have some of the things with NoSQL. Now, if you see, you're only one thing which is being supported by NoSQL. Just one table, if you see, and that is your
Videos.
videos attributes. Apart from that, nothing. Rest of the things from NoSQL, now you are moving to SQL. Right? Initially, we started with NoSQL. Now we are thinking that we'll keep everything into SQL. Just the videos attributes will be kept into NoSQL.
Are we sure we did NoSQL doesn't support transactions?
Yes.
Okay, there was a recent MongoDB version that probably, I don't
Matlab,
know.
recently, let's say,
Yeah, so because
recently there will be, yeah.
I just watched, I was doing a tutorial and I did it, so that's what I was thinking, like, does it not support or
So
okay.
like let's say, matlab, when I worked on MongoDB, there was not few
Okay,
years
fine,
back.
fine. Recently there is probably,
Huh.
maybe I'm not sure, but probably there is.
Because
Uh,
it's in need of recent time, so
yeah,
probably they
exactly.
would increase it.
Yeah, yeah, yeah. Okay, so let's just assume they don't support it for now.
Hmm. Like Cosmos DB is there of
That's
Amazon,
Microsoft.
Microsoft. It has the joins as well. So
Ah,
and the SQL kind of on a query system as well, where you can join. So
do
it
you
is
do
like
they,
way.
do they ask that which tech stack will you go for? Will you go for like a Linux and all that PHP, or will you go for like a Microsoft tech stack, or will you go for like
In
Oracle?
an interview, would they ask like that?
Probably not, because they would just worry about what they do, right?
Yes.
Yeah, okay, fine. Just
So
wanted to clarify.
so generally they don't ask because everything can be coded and handled in every other tech stack. So
Okay, fine.
which tech stacks you are using? So now let's discuss in terms of scaling. As we thought that SQL is vertically scalable. Okay, if you read about scaling with a SQL, majorly you will read that SQL is vertically scalable and NoSQL is horizontally scalable. So far we have discussed about the scaling yesterday. Which one do you choose in terms of scaling? If you are just thinking in terms of scaling, which one will you choose? You'll probably choose NoSQL. Why? Because horizontal scaling is better. Vertical scaling is little bit still not that best. But there can be a vertical scaling kind of on a system in SQL as well, like a distributed thing. You can have a master for read and you can have slaves for write, or vice versa. Write into master, which is heavier system, and read are happening from any of the slave system. Such kind of distributed architecture you can also use with a SQL, MySQL probably, let's say, or Postgres. You can use the master size is large and rest of them are slave. Whenever the master goes down, let's say one of the slave will become master. Such kind of system can be applied with the SQL. So vertical scaling cannot be done with a SQL. It's not correct. It can be. It's just that you need some extra, one extra instance of master or something like that. So now in terms of scaling, we'll think that, okay, that is also not correct, though probably majority of the, what we can say, uh, uh, internet article says that vertical scaling is not possible. So with SQL, it's not the case. Now let me tell you one fact. Though we think everything that SQL may not be the right way, or only it is for the user management system and all that kind of system, let me tell you, YouTube was completely built on SQL, while Netflix, which is newer system, is completely built on NoSQL. Yes, for transaction and all that things, probably user management, uh, the MySQL or such kind of SQL would be used, but rest of things, From initially, YouTube has on SQL, all the attributes, this, that, everything. Now
Yeah,
probably
but
they are transferring.
how do they how do they do like query? How do they query two different systems? Oh, it's just a microservice, is it? So what if the same service needs to? So for example, a system that uses NoSQL now needs to contact the SQL based database.
So it's
So
always like this, right? That
to
you
have
have on a
different
server,
connection.
you have,
Okay.
let's say, server. So server will query to NoSQL, and it will check that for this it needs some data, and then it will query to some other system, right? Now if you have a proper subsystem or a layer on that between as well, let's say
Like
DB
an
layer,
interface.
like a
Okay.
DAO layer is there. So mostly DAO layer we are putting into the server as well, or the
What's a DAO
microservice,
layer? Sorry.
database access layer,
Oh yeah. Okay.
right? Let's say DAO layer, you have kept it somewhere else. Just like you can just query the API and then you can get the data, then also you can do the API call and then you can get. Or if the DAO layer is coded inside only, then that will take care of which connection string to call and which data to come, which data to bring to server. Server will decide which again further to call. So that
Yeah.
will not be a much
Yeah.
question.
Thanks.
But
Yeah.
point is that though we think that this kind of architecture should be by SQL only or NoSQL by only, it's not necessary that this is only the right choice or this is only the right choice. Both can be done for a system. As I said, YouTube was using so far SQL only, and very successfully it was using. And Netflix has started with NoSQL only. So it's not like that you cannot have scaling with SQL or NoSQL. Typical type of scaling, one single type of scaling. You cannot have some type of attributes with this and not with this. Probably you can store attributes in a string in one column, simple. Now you can add as many attributes along with the video into single column. No need to add multiple columns as well. A very simple example, right? You can convert or JSON's convertify all the attributes in a string, and you can store it into one row or one column of SQL. And then whenever you want to use, you can retrieve it, use it, and then you can again store it back, isn't it? So with the SQL also, I can have multiple attributes of the video. So it's not like this is always right or this is always right. That is what I wanted to say. And why I wanted to say, because with different systems, sometimes we can see that the answer will not lie towards only one database system. There are certain examples where NoSQL will be only the best fit choice, and we'll see those. Okay, but for that also we can see that we can use the SQL. It's just that when we use the SQL, it will be less, just more, stringent process to handle all this data type. We'll see that. Okay, so far in terms of scaling and all the things, we thought that one type of database is better. And now if we see that modeling, query, scaling, usage, all are on the topic, if we see, we think that anyone was better. We have discussed about all the things: scaling, usage, ETL, acid base, search engine, Elasticsearch, cost, hosting. These are the also few of the points that we need to consider, that what will be the cost of this and this, what is your what is your data, right? How much it will be read, how much it will be consumed. Based upon that, you need to choose this or this. Agree? Because let's say MySQL is coming as free and NoSQL, some of the database, let's say, is coming at some cost, then you will always go for this. Why? Because you have an open source system. You are not earning from that initially. So you'll go for that. How much the charges will be for that hosting, that also you need to think. But if you see, majority of the companies have started with Java. Why? Because Java was free. Java servers were cheap and reliable. .NET was also giving the same kind of benefits which initially Java was giving. Later on, Java has many more features, uh, and now C# has also the same kind of features. But still, number of Java servers or the companies which are reliable on Java are very high. Why? because
Free.
their initial cost of the servers and hosting were very easy and cheap, and it was free of the cost, right? So when you are deciding any of the thing for your system, when you're designing, you need to think about this as well. Okay, so we are just listing down what are the points to think about. And this was the thing that user management will keep with SQL, videos will keep on NoSQL. And this is what I said, that YouTube was completely on SQL and Netflix was completely on NoSQL. So it's not like that you cannot use this. And post that, we have also discussed about the scaling of it. Okay, this was one of the things that we discussed, that we'll put the video into systems like S3 or BlobClob, or in Netflix we can use HBase or Cassandra for high read videos and all that things. Then we discussed about the scaling. So let me just give a very quick overview of that. A normal tendency is that the SQL can be only vertically scalable, while NoSQL can be horizontally scalable. That is what is general perception. But there can be a system like this when you have a master and you have slaves. Such kind of subsystem, you can have vertical scaling with SQL as well. So you need to know all the types of possibilities and tell you it's not like this is not achievable. Flipkart was using this.
You mean horizontal scaling?
So in my team warehouse, we were using SQL for
Yeah.
all the entries of the items.
So here, master and slave means horizontal scaling. Oh,
Yeah, distributed. I would say distributed
okay.
architecture, not just that. So horizontally it will be scalable. Why? Because you will just add extra read instance if your reads are getting chalked, or if your write is getting chalked, you will create such kind of another system along with it, right? Or you'll remove this master so that one of the other system will become master. You will increase its size and you will put back it as a master again. So the point is, you can scale the whole subsystem with a SQL as well, horizontally and vertically, both ways, right? And this kind of system we were using. So with this, we have seen that what are the high level components that we need to think about in high level design. In that, we have to think about what are the system we need to think, what are the components you need to think. As I said, ELB, CDN, cache, distributed cache, so many things kind of component we have seen, systems we have seen. Along with the system, we have seen which kind of services initially we will create for each and every system. It can be still drilled down furthermore, that one service, let's say security service, can have multiple services, or one system of security can have multiple sub-services, microservices. So that kind of an architecture we can still drill down. So it will go as per the flow in interview, that if interviewer is more interested in terms of knowing about your knowledge in terms of database design, he will go towards that. If he wants to know more about the system design in terms of microservices, he will go and discuss in that way. But what will be helpful to you guys in high level design is your broad perspective. That is what I tried to give you, that you need to think about each and every phases or aspects of the system design. And you guys can think that you can guess, can understand that we started with normal user management, we added some systems like security and this, that, and so many things, right? So you need to have a broader perspective. Okay, and you guys must have well read about all the components as well, like what is the way SQL can be scalable, NoSQL can be scalable, and rest of the things. Now, furthermore, I'll just give the gist of what you guys need to read about it, and then we will take further few question on design pattern. Then one of the question will take about the SQL design and all that thing. So let's see first what yesterday we saw that you guys need to read about it. And these are the few things. You need to know about the queues. We started from that. SQS and Kafka are the type of queues. Okay, what are the benefit of SQS? What are the benefit of Kafka? Yesterday, I think we discussed about Kafka is you can read from the threads and all that things, but SQS generally gives single read operation. So that kind of differences are there in terms of tools, but where it is being used, that you guys should know. We'll take one example where queues are being used in system design. Okay. Furthermore, we have also discussed that what other things that you need to read about. So the APIs, I said that what kind of REST APIs you will create, what are the other type of APIs you can create that you should know, and what are the standards of the APIs. There are multiple, but which is the widely acceptable ethos standards. So you should know about it, because there can be some teams, some companies need that you should know about it because they are following those standards. And as I said, let's say in Amazon, there is one of the team which is utilizing or which is giving services to 5 different companies. One is of US, one is of Europe. Let's say payment services, or let's say prime services or something. Okay. So what happens is everyone needs to have a standard process of calling that API and all that things, right? So you also need to maintain a standard process. So that's why generally it happens that whenever you go for interview in such teams, they will see your knowledge, that do you know about it? Do you know how the model API will be modeled along with the ethos standards? It's not big deal. It's just in terms of parameters, how it is being used, but you should know about it. Okay. Now, furthermore, yesterday I gave you the thing that you need to know about the microservices, how you should distribute the microservices. What are the issues with the microservices? I think just now I said that if you're creating a microservices, your transaction may not be possible. Just think about it in this way. Okay, I'm just giving you an example, because let's say when you'll design a microservices based architecture, person probably, if he wants to pull your leg or he just wants to know that how much really in-depth knowledge you guys have, then he'll ask you such kind of question. That let's say you are designing a microservices for warehouse. Okay, so for warehouse you have few systems, order management system. Once the order is confirmed, payment is done, the order will come to warehouse system. Now in warehouse you have few of the microservices. Let's list them. Think about it. In warehouse, what can be the microservices? Let's say you can have availability services. Availability services means before taking an order, or whenever the order is being placed by order management system to you, you will check whether it's available or not. If it's available, that it can be fulfilled, then you will accept it, otherwise you will return false. Okay, so let's say there is one availability services and there is one transport services. There is one transport services. Now if it would be that warehouse is a monolithic system, your both work of availability and transport system and everything would be there into one system. Now consider a scenario that whenever you are placing an order, you are checking warehouse. So you are querying to warehouse. Warehouse checks whether the availability can be fulfilled or not. If yes, you'll directly, because order has been done, payment has been done, you'll directly reserve this item. Let's say you ordered a Maggie. So that Maggie will be kept for you and it will go for the transport system. That okay, now transport this whole order. Consider it Maggie and some atta and so many household items that you have ordered. Okay. So you have ordered, you have selected cart, payment, everything done. It came to the warehouse for the order management via order management system, and it can be fulfilled. You created a transport and you are sending it. Okay. So the system from the availability, it went to transport. Now, just after 3 or 4 minutes, you are canceling the order. Now, if it would have been a monolithic system, okay, before you call a transport system, you could have checked whether the order has been cancelled or not. If it is not, then only then the transport entry in DB would have been created that, okay, this object should have been transported to this user. But in this case, what will happen? That your availability system said yes, and then furthermore system would have other system, let's say repository system is also there, or repository service is also there, that will reduce this quantity from it, and then it will create a transport request. So the transportation has been done, then the cancellation happened. Now over here it would be easy because it is just into one transaction. If let's say something failed, repository could not reserve this item for you. The repository services, like exactly the warehouse services where the items are kept, it could not reserve the item for you, or somehow something happened and one of the system fail in between. As I said, availability reservation system for the system, and then the transport system happens. Let's say reservation failed. What would have happened? That is one thing. What would have happened in a case, let's say if something failed and we are canceling the order, what would have happened? If it fails, your order is in dangling state. Order has been done from OMS, availability has been done from OMS, reservation or reporting system has said that item system, whatever, it has said that, okay, this item has been reserved, then the transportation system failed. So everyone knows that, okay, order has been done, but only transportation system says that, okay, I cannot fulfill the order. What will happen? Because in terms of microservices, this service, OMS has called this service will call this service, and you will not wait for everyone's response. Otherwise it will be as a monolithic system. You'll just call the API and you'll forget it. That is actually the microservice based architecture. You'll post the API and then you'll forget it. You'll not wait for response. Otherwise what it will happen? It will keep on waiting for each and every subsystem to respond. So that is not the exact way of microservices. Microservices is just like, you did this process, I'm done with it. I processed the availability. Rest of the things, I created an order with the repository system that, okay, reserve this repository. And repository said, okay, I have reserved it. Now send these repositories or items to a user. Right. So if it fails over here, you cannot revert back whole transaction. That, okay, reservation also should be revoked. Availability also should be revoked, and order management should be notified that, hey, we cannot fulfill this order. This kind of things will not happen with microservices. Same thing, if the cancellation happens, again the same thing will happen. Order management system got the cancellation, then again it will have to call the availability system that, hey, do you have processed this order? He said, yeah. Do you have processed this order? You said, yeah. And then the whole channel is broken. You have to point, or you have to create a proper system such that the cancels are handled. Right. Otherwise it might have happened that transport also will say, okay, transport request has been created and the order has been gone. Let's say after 2 days you are canceling. It may happen, right? But in 2 days the transportation system has transported your items and they are in transit. Let's say they are at the doorstep of Bangalore, and from Bangalore it is coming back to your home tomorrow. But today you are canceling. So what will happen in that case? Microservices based architecture probably may not handle this easily, but monolithic can handle it easily. So the point is, what is best? This one or this one? If this one, how will you handle, as I said, transaction? Canceling, probably you can have canceling API at the transport layer, repository layer, and everything, and it can be done. Just like reservation, you are reserving some item and then you are transporting it. The same way you need to create a channel for cancellation. So that can be done. Cancellation can be handled. But what about the transaction? How can you handle the transaction easily with microservices?
You need to have a status of each and every stage where the product has gone, and then based on where they've clicked cancel, you can try to revert it back and have some rules based on that.
But see, microservices means what? You have some
Distributed,
independent
systems.
Yeah, you have independent system. It has only 5 APIs. It will just check availability. That's it. Let's say this system's main work is check availability. Reservation system's main work is to reserve the item. Main work, I would say, reserve the item. Check the reservation and reserve the item. And the transport systems thing will be just to transport the thing. So what will happen, the kind of an API will be exposed, will be like that. So when one order came, you check the availability is there, then you say, okay, make the order. So that will call to reserve system with an API that, okay, reserve this item. And along with that reserve, after the reservation of the item, you'll call an API by telling that transport this item. Okay, so there are three independent API calls. One return successful, another also return successful, another also return successful. And in this case, return is not possible. Why? Because you are not creating a system in which it waits for all the transaction and everything to complete. Otherwise, it's just like a monolithic system. It's just like it will does its work, it will call the system and it will forget. Right? That kind of an async architecture only should be there. Otherwise, number of requests it cannot handle, that much load it cannot handle if you are keep on waiting for each and every system to respond, right? So
Can you
all
have
the
another
call,
system to manage the transaction?
then it is just like a monolithic, right? Let's say you have another system which will keep, okay, this call has been done, it will
Yeah.
return, then this call has been done, it will return, then this call has been done, then it will return. Then in terms, it is a monolithic system. Just there's the uh, deployment is a different way, but you have kept it a sync order. Monolithic is a sync. In synchronization, first step happens, second step happens, third step happens, and fourth step happens. After all the four steps happen, then only then the process completes. Over here, what is there? One process complete, then it is free, so that it can take another threads to process. In that way only you can have a high load architecture, right? Then only then it can have a very high load. It can handle very high load. Then this system will handle, then this system will handle, and then this system. So all four systems are independent. Now, if you want to put a transaction in between, if you keep distributed system like this, it's a useless. You cannot have the high load. What you will do? So it's an interesting issue to read about it. Read about it. There are multiple ways to solve this problem. Okay, as you said, one of the ways distributed system, that you keep a distributed system, but it will break the benefit of microservices based architecture, which is async based architecture. You need to think about something else. Okay, one of the ways queuing based architecture, or the what we can say event driven architecture. One of the ways event driven architecture, read about those as well. The easiest way would be event based. Then there are some of the protocols that can be used to handle a transaction into microservices, but they will be slow. So read about those. There are 2 to 3 protocols, I think. Okay, one we have implemented in warehouse, I remember it, but it was slow. So then we went back to again event-based system. So it was POC, but after POC we find it out that for even trial orders it was not able to successful. So we went back to our previous model of event-based, which we thought. But it's interesting to read about it. How will you handle the microservices for the transaction? Read about it.
Dhaval?
Yeah.
Yes. Actually, if you are talking about microservice, then microservice is asynchronous, and
Yes.
asynchronous can only be implemented using queue. Am I correct? Because I just wanted to.
It's not like always a queue. It can be simple API calling based thing as well. So let me tell you. So let's say you have one subsystem or one microservices, and you have another microservices, just like our previous case, and you have another microservices. Now you can implement it in multiple ways. One way, which is very easiest way, is that when you create an order or when you call this API, one of the API, the API at the end will call another API, and it will not wait for it. It will just call the post API, and it will not wait for it. It will not keep the port open. Okay. Now, when this processing done, it will call the API. Such kind of a system you can have. Another kind of system you can have is this microservice. Once it is completed, it creates an event in a queue that, okay, I have processed this order. Next system should process the orders from the queue. So this system will read the queue, get the message, and it will process the message and again creates the queue. Message into queue. Further system will read from the queue and it will process. That also can be there. So it is event-based architecture. You generate the event, and the benefit of that event kind of a system is that another microservices also can read the event. Let's say you have a recommendation system, you have some other systems, like let's say here is in a fulfillment order management system kind of a thing where the items have been reserved. Now here is in a warehouse management system which or other services which checks that okay, this many number of orders have been completed, so I have to order from another warehouse or another what you can say seller to fulfill this order or to keep the inventory into items into this order. So let's say number of atta packets have been reduced, 10 kg atta packet have been reduced below threshold, so that it will keep on checking that how many orders can have been happened on this warehouse. It checked, gone below some threshold, and it will create an order from nearby warehouse to in own warehouse. Okay, so let's say Bangalore has 5 warehouses. So from one of the nearby warehouse, it will create an entry that okay, give me an order, give me few kgs of packets of atta or whatever. That kind of order it will create, or it will create to a sellers. Let's say Pillsbury attas are there or whatever. Okay, Ashirwad atta are there. So it will create to that seller, and it will create an order that okay, do send me this many number of packets of this item, right? So such kind of subsystem is also there, and they will also consume the same events because it will be only necessary for them because 5 number of some repository has been order has been came, it has been reserved, so obviously it will be reduced from the thing, and you need to keep on checking that if it reduces for one of the threshold for one of the warehouse, you need to call it again, or you need to bring that item again into the warehouse to keep the availability of that item on the go, right? So the event-based architecture in this kind of subsystem is best. Event obviously will happen with a queue. Great, got it. So async can have multiple ways. Best way is this. So we saw about that what can be the issues into microservices. Best is, or one of the crucial is transaction, and there are ways to solve it. I would recommend that you guys read about it. It's a good thing to read about it.
Now, one last question means using queue only we can do a event driven architecture.
Yes.
Okay, thanks. Okay, got it.
Okay. Now, furthermore, in system design round, what you guys need to read about it, okay, before you want to go for it, is that you need to know about the DB schema. In which way you'll design a DB schema. There are multiple ways to design DB schema. Okay, it's just not normal table-based architecture or something like that. You need to know where you'll put the ACID properties, where you'll not. Okay, how you'll do the scaling. Do you go for the sharding or not? Which kind of tables you'll create such that the joins are supported or not? Or do you need some other kind of NO-SQL kind of an architecture or what? So you guys need to read about these things as well. And when I say it's schema, you know about the normalization, right? That you have 1NF, you have 2NF, you have 3NF, you have BCNF. This would be your 4NF is the best one. Then there is 5NF, but it is not useful. And you have 6NF as well, but it is also not useful. It's very much normalized architecture. So this kind of things is not useful. But which kind of system will be 4NF or BCNF? That you guys need to read about it, right? That if I'm designing a school management system or something like that, what is a 1NF, what is 2NF, what is 3NF, and what is 4NF for that? If you read about few of the example, you'll know that, okay, such kind of normalized architecture or schema I need to prepare. We'll take an example and I won't take the example of exactly what is 1NF, 2NF, 3NF. It's a bookish one, but in which way you need to normalize directly, that thing we will take it up. So not to worry about that, but you should have read multiple, examples of that at least. You should have the knowledge of that at least. Also for the sharding, right? SQL can also support sharding. NO-SQL can also support sharding. In which way you should shard? Probably any one of you have used the sharding in their system or in your company.
There is a Solar. My company uses Solar for indexing. That uses sharding by default.
But on which basis shardings have been done? Sharding means what? You are
So copy is like a replica, right?
no.
Okay. Okay. Sorry.
So sharding is what? Uh, Consider it something like that you have a huge DB. Okay, you are creating some partitions of it. That let's say all the users whose name starts from A to B is coming into shard 1. All the users whose name is starting from B to or C to E or F, where the less number of users will be there. So the size of one shard is 1 TB. Another size is also 1 TB approximately. And F to P, less number of users name would be there. So its size is also 1 TB. So what happens based upon whatever the query you are doing, where the student name is Abhishek, you'll only query into this shard so that the search will happen into this. So this is whole DB, but into one sub part only your query will go. So you do not have to read into the whole. So indexing will also be a separate for each shard. So consider that this is another database, another database, another database, another database. Consider that in terms of logic, but physically this whole is one database. So when you go for sharding, you shard like this. In database, you are sharding your tables, or even a single table is sharded into multiple places. So consider a DB, or consider a list of DBs into one DB. That kind of system, logically you can think as sharding. You are sharding your partitions, or I would say you're sharding your database or tables or data in such a way that it can be easily queryable. So read about it. What are the parameters that I should read about it or think about it before sharding? Now, if you think about YouTube, probably if you are using a single server to store all the database, probably you can shard by region. That all the US videos will be into one shard, all the India or Asia specific videos will be into one shard, and so on. If it is not found into one shard, it will be try to find it into another shard. That can happen. Okay, whenever you are sharding for any of the MySQL or NoSQL, any Mongo or anything, they internally will take care of it. But after sharding, your retrieval will be faster. So how you are sharding, that is also important. On which parameter you are sharding. Region, local, as I say, that can be one way. There are separate ways as well. So read about it. It's pretty interesting topic to read. Few of these slides, if you read somewhere, slides, I would say not slide, but few of the sites.
Would you suggest a book?
No, book will be very huge, and in that they will explain. Let's say in NoSQL, if you go, then probably or SQL, if you'll go, they will explain everything regarding that. You know how this kind of system would have been sharded, or what will be the
No, I'm talking about
parameters for
more
that.
like an architecture book. So like if you have like a system design architecture book, they generally give you like what is the best choice for your like what type of questions you should ask, and based on those questions, what choices should you make. So do you have any suggestions on that?
No book, I won't have. I also haven't used any book for that, but I'll try to find it out. A good
Okay.
book. Okay, like for data structure, I know few of the books, but for system design, there is no exact book I have encountered so far.
Fine.
Okay, now there is, so in a queue we have next question on what we can say design pattern. Let's get started about, because we have started with YouTube, let's go and think about it in different way. If you have to design a Google Calendar, now when I say Google Calendar means what, you can send an invite for some event to your friend. That is what I want to design. So as a client, I'm giving you just this requirement that I want to design a Google Calendar kind of in a system for my system, internal system, where I can invite my friends. That's it. Now for that, I'm asking you directly to give me database design, no high level design, nothing, no SQL, no SQL, which kind of thing. Directly, I'm asking you low level design for that. What kind of system you'll think you'll start regarding the schema system, in the sense schema, you'll start creating it. Can we start? You guys need to answer for that. So
Yeah. So you need. So are we maintaining who has what friends, or is it just email based? We would just like email people who are my friends.
yes, I'll just add the email
Mhm.
ID. That's it. Right now, let's
That's it.
say I'm just giving an email ID. So first thing is main, which you asked about it, is you keep on asking question about requirements. Whenever you think something, you ask the question and change your schema accordingly.
Yeah.
Or you first narrate all the requirements which comes into your mind. That is the best way. Okay. And then you start designing the schema. So let's start with that. What are the requirements that you can think of? So first you say that, okay, are they friends or not, or something like that? No, you don't need to keep the friends list. You can just add an email ID.
Hmm.
Okay. Second thing.
Uh,
Duration means the timings.
Yeah. So what are the things will be there for invite?
events like
Yeah. So event, what
event.
are the
Yeah.
parameters of the event, right?
Yeah.
So
Yeah.
parameter will be like, it will have the event title, that I'm calling everyone for my birthday party, let's say. Some
Mhm.
text that I'm
Location,
sending them. I'm sending them that where to come, which is like location, and
timing,
date and time, that on this day from this time to this time this event can be. Okay.
reminder.
A reminder can be another system.
Okay.
It's not, but yeah, you can add a reminder as well. Now reminder may not be the part of design or a schema of the calendar, right? Because there'll be some system which will read that do you have an event today, and then it will give you the reminder. So
Mhm.
in the design of DB, probably you will not need the reminder thing, but yeah, that's a good thing to think about. Next.
Uh, you need calendar.
Exactly. Do you want to view your calendar?
Yeah.
Yes, I want to view my calendar. I want to see that which kind of events I have for today. Can
Accept
I
or reject event. Maybe.
exactly? Can I accept someone's event, or can I reject someone's event? Can I cancel my sent invite? Right? Is this operations allowed? Yes. Okay. Let's say so far so good. Let's get started. What would the first table that comes into your mind? User.
Yeah.
So probably you think, okay, I'll create a user table who has a user ID, user profile. Now, obviously, user profile will be a foreign key of some, where you are storing so many things. Okay, so let's not go into that. And as I want to see my calendar separately, I'm keeping a calendar ID, right? I want to see my calendar. So that calendar ID I'm giving separately. Now, why calendar ID is separated? You can have a normal calendar, and on top of that you are just adding all the events. Then also you can create a view, right? But I'm segregating my calendar ID. Why?
You might have some other settings for that
Exactly.
calendar that you want to kind of save. That
Probably.
way you can.
Probably, like in India, it's in a Georgian calendar, everyone knows. But in this countries, what we can say, Middle East countries, they are using in as far as I know, in their so far they were using that Hijri calendar. Like also in Nepal, if you see, it's in a Vikram Samvat calendar or Sak Samvat calendar.
Oh wow. Okay.
Yeah. So for Nepal, it would have been 2070 or something. Even Indian
Hmm.
Vikram Samvat, and they follow the
We
same
do
thing.
as well. Yeah.
Yeah. But the point is, in their day-to-day life of country, they are using this date
Yeah. Hmm.
in the coins, and their notes. You can see that In the same way, for Islamic countries, they are using Hijri calendar. Okay, so probably based upon the region you are, based upon the starting of the day, let's say starting of the week, probably your calendar can be segregated, right? So you are specifying a calendar ID, which kind of a calendar ID you want to associate yourself with, right?
Yeah.
So something, we thought something new. Apart from that, what other table do you think?
Event table.
Okay, event table can be segregated or it can be part of calendar. It can be, right? So let's think about that. If I want to add calendar, it can be like this: calendar ID and rest of the details, like the visibility of calendars, which kind of, if this calendar can be visible to my friends or not, or if, then which friends. Like if it is a manager and junior relationship, I'm giving that only my peers can see my calendar, something like that. So that obviously it will be a huge system, but some components for visibility you can use. And the easiest one will be the list of email ID. Who can see your calendar? Okay, calendar ID means the type of calendar that you are using and all that things are there. And the list of event, what are the types of event that you are putting into this calendar? Okay, that would be the simplest kind of a design. Then we can evolve based upon it, because this calendar will be a normal view calendar, like it has 365 days, that's it. Then on top of that, for each day you are adding that which events are there. So then we need to think about event system or event table. So event ID can be like this: event ID, visibility, to whom is it visible, and the list of invitees. Anything else that you can think about in what can be done, what can be added into event table?
Location.
Location and all that things. Second thing, as just think that there is an event table. Okay, how will I know from that event table who is the organizer of this? How will I differentiate that? Am I the organizer or am I the invitee? Right? So I need to have some parameter like who is the organizer, who is the email ID of that organization, right? Because as if you are invited, this event will be also part of your calendar ID. And if you're organizer, then also this event will be part of your calendar ID. But some parameter will be necessary to differentiate that. Okay, furthermore, or you can have something like this: what are the list of events that you are invited to and what are the list of events you have organized? Then also you can segregate, right? If you do not want to keep the organizer over here, then these are the events which you are invited and these are the events that you have organized. Some such kind of a list also you can segregate. So it's okay which kind of design you are going for, organizer based or difference. If you are differentiate the event based, probably this kind of design may be better because you can accept and reject based upon this easily. Now, anything else with the event? Let's say we are going with the organization. So then organizer ID. Who is the organizer of that? Then you have something else like description, textual description. You are inviting everyone with some of the image. So let's say file ID also you are associating with it. Then you have time, like from date and to time date, right? Now here, do you think that this kind of design is correct? So far, whatever we have designed, do you think is it correct?
I'm not sure about the list event in calendar.
Okay. So what you are thinking so far?
So I think you can have the calendar ID inside the event as well.
Why? So calendar will be a type of calendar. An event
Okay.
will be part of it. You see it in terms of your this one. What you can say? Okay, consider it something like this, that this calendar has been shared between two of the email IDs. One is your office email ID and one is your this. Okay, then
Yeah.
the list of events which are part of your office are part of your calendar object or part of that. In the same way, so I'm talking in terms of in real life how the relationship is. In the same way, you need to model it in code as well. And your personal events are part of your calendar. You can sometimes add some event as part of official calendar or personal calendar. So
So
the
we
point
have
is
that in like Google Calendar. The Google Calendar just has based on email. There is no type work or home or something like that.
exactly not it, but I can add. So let's say if I have got some email and I want to add that reminder at that event from my office mail to this, I can just send the mail and that event will be created over here,
Okay.
right?
As
Obviously, they both will not be associated, but
yeah, so one calendar will only have one email as
one,
in like
yeah,
owner. Yeah.
ownership like that.
Yeah. So that way, so if you have one owner for a calendar and you have a list of events within that calendar, you can just, so because to normalize the table, you don't want to keep repeating. How would you have a list of events, for example, if it's a SQL design? You won't have a list of events, right? In a NoSQL, you can have list within the
You
same
can
table.
have the list of, so
Is this, are you doing classes or is this database?
it's a database.
Yeah, so classes wise, this would have been fine, but database wise, I think you need to move the, so you need to bring in the event like, so this, I don't know how am I explaining this, but yeah, so you have to have the calendar ID within the event. So that way you can create a list of events within the calendar.
So what you are telling is either I can have the list in the terms of string over here. That is one way. Okay. Or the second way is instead of such kind of relationship, I have the calendar ID and event ID relationship table, another
Yeah, so
table.
you have a linking table. Yeah.
So yeah, we have calendar ID 1 and event ID 1, calendar ID 1 and event ID 2. So linking table. Yes.
Yeah. Yeah.
Agree.
Yeah.
Agree. So yes, this was one of the thing.
Yeah.
Agree.
Because the database wise, I don't know how to achieve lists apart unless it's a NoSQL database. So that way
Agree.
you can, yeah.
Agree. Agree.
Yeah.
So if it's a SQL, you can go for this. If it's in a NoSQL, you can have the list. No
Yeah.
worries.
Yeah.
Perfect. Anything else? With just all these parameters, does this system design or DB design either in this way or in this way? JSON-based architecture. Okay. Anything? Is it fine? Do you see any mistake in this? Harsh, Karthik, Anurag?
I just saw this list event.
Okay,
Apart from
Rishi?
that,
Okay, let me ask you this question. That Harsh, I'm sharing some event with you
okay.
or with Rishi. You both are at different time zone, and we three are playing a game together. Let's say PUBG or anything.
Mm.
What is your time zone and what is your event would have been created? What is my time zone and what is that created? Is it being handled over here?
No.
Okay, that was my first question. Now, second thing is that let's say are this event only, probably. Okay, which is lasting from morning 10 to afternoon 1 for me. So 10 a.m. to 1 p.m.
For me, it's
On
5:30.
for you it's 5:30. That's
Yeah.
perfect. So that will be handled in time zone.
Okay.
But where I'm now going at, probably for Rishi, yeah, we can store the time zone. That is perfect. So that internally we can convert the date. Okay. Now my second question is that probably for Rishi it is two events or the 2-day event. So for Rishi it will be like what is day today? What is the date today?
16th.
Today is 16, right? So he
Yeah.
would have like 15th of August night 11 to 12 one part of the event, and 16th of August 12 to 1 or 12 to 2 second part of the event. So this event has been segregated into 2 days for him probably. Am I right?
Yes. Yes. Very true.
Is it being handled over here? Even if I add the time zone, is it being handled over here?
But how can you handle all of this in the data on the database side? Because this is more like when you create an event,
Mhm.
that's when you will. create like for based on which user it is for and where the location is or whatever the location is on that account, you will do it in the application side before saving, right?
Okay.
Because
Okay.
you can also have like you can have triggers and you can have procedures which get executed, but it's just
Exactly.
easier on the application side.
Okay. Makes
Okay.
sense.
Yeah.
So let's say for me, this event when I've created, I don't know, somehow this erase is not working. Okay, erase. Okay. So let's say for Rishi, the event has been created like this for Rishi. Okay. And for me, same event ID is same. For him, probably the event ID would be separate because the whole user, because he's invitee and I am the organizer. So for him, the event has been created like this: 15th August to 16 August, 12 p.m. or 11 p.m. to 2 a.m. Perfect. And for me, event would have been created 16 August, 10 a.m. to 2 p.m. Let's say IST and it is PST. Perfectly fine. Now, Rishi is logging on the 15th morning, and which event he could see? Can he see this event? That you have the event from 15 to 16 at 11 p.m. to 2 a.m. Can he see that in his calendar view? Yes, right? He should be able to
Yeah,
see
you
it.
should be able to see that part at least. Yeah.
Okay. When let's say he wakes up at 16 at night 12 or night 1 and see that do I have an early morning meetings at 8 a.m. or something like that, and he just want to see, should he be able to see this event as well, that you have a meeting from 16 which is actually going from 15 to 16? So should he be able to see this event as well?
Yeah, you can have multi-day events, right? So same way you can create a
Ex-
multi-day event for someone who's in a different time zone.
exactly where I was going.
Yeah.
That for such kind of things, how will your query system will work? If you have from date to to date, if you have from date like 15th August,
Yeah.
11 p.m. to 16 August, 2 a.m., such kind of architecture, if you are storing into your event
Mhm.
table, then how will your query will work, or what will be the uh, operation cost on the query? Because what you will do query, that what are my events today, what query you will do, select star from date. Now what will be your date? Are you getting my point?
Yeah.
What
So
this query will look like, because I
sorry,
want to see the calendars on 16th, I want to see my events on the 16th.
yeah.
So if I'm storing like this, what my query should give me, or what should be my query such that it gives me that okay, I have an event on 16th?
Uh,
Everyone got my point? Everyone got the question?
yeah, yeah. As in, can you repeat that once more time? One more time?
Okay, before that, Anurag, Jose, Karthik, Rishi, you got this point,
Yes, Dhawan.
right? So what I'm asking is, if I'm storing my event like this, start time from date or to date, something like this, start date or to date. From 15 August, 11 p.m. is my from date, and to date is 16 August, 2 a.m. Now, when I'm logging in at 16 early morning, let's say anytime, night to 12 or anytime, and if I want to see that what are the events of my today, what are the events that are going on or are there for today, I should be able to see these events. That is true. But what will be internally query, which my system will create, such that I should be able to see this event? Select star from event table, where date, what it should be.
So if you're looking at 16th, it should be 16th.
No, because what should be your date? See, it's
Oh yeah,
from
yeah,
date
yeah.
to
Okay,
date.
okay. You just do. So it depends on the view you have. You have the month view, week view, that way.
Yes.
Is that
So
what?
let's say I have an only day view. Let's say
Okay. So day view, or so you're looking at only the 16th.
yes, only the 16th events. And
So
why
you
am
just
view? Because the view, even if it's in a week view, there can be an event which is in last week and this week, Saturday to Sunday and Sunday to something like that, Sunday Monday, right? In
Can
the
you?
same way for the month as well. Let's say in office, you have 3-day outing.
Yeah.
So one is on 29th, another is on 30, and next is on 1st. So
Yeah.
even if you have month view, your event is distributed. So event can be
Ex-
distributed between days, weeks, or month,
Yeah. Yeah.
right? So I
Yeah. Yeah.
cannot, so views is irrespective of this query. So that's why I have said that, okay, just think about the day.
So
Which
you're
kind
just
of,
querying which day. So you just want to see on 16th how many events you have.
exactly.
So you'll just query for that date. What's the big deal on that
Give me the
one?
query. Give me the query. Okay. Based upon
Uh,
this event, give me the query.
Select star from event where date. If it's SQL, then date equal to cast. Like a date string 16th hyphen Jan hyphen 2020, and then as
So you are
date time.
saying like this. Okay. Select star from
Or you
event.
can do select event ID if you want instead of
No,
star.
event ID I don't have, right? Okay, okay, just go for star. Okay, where?
Okay.
What date? From date or to date? Right, because you have from date and to date.
Yeah, I think you would have to calculate between
Okay, how much
where
time it will take for between? Okay, if I'm going for between.
where date where sorry where event date. No, you can't do that as well. One second. Um,
So let's say this is today. Okay,
mhm.
let's say today is 16 or time dot now, something like that you are passing. So you are telling that today, let's say, should be between today dot between from date and to date, something like that, kind of on a query you created. But tell me, what will be the performance of this query?
It'll be slow. Any between stuff is very slow.
And if your table is like YouTube like or Google like in a
Yeah,
table,
you don't want to use it then.
exactly. So what kind of now structure you'll think that is it the correct structure?
Um, so you can for that event, can you have like like
Okay,
like
okay, okay.
number of days inside, as in you don't have
Will
to
that
show
help
it.
me? Will that help
uh
me?
you can then you can query just one aspect, like you can just query from date and then count the number of days, and then
So what will be the from date? See, I'm checking for event on 16th.
yeah.
Probably it's an official event of 3-day outing. So from which from date I should go for?
From date will always be the same for that event, right? That won't change.
See, you have the number of days like 3 over here. So you have something like this. 15 is a starting date and number of days are 3. And now I want to check that what is my event on 16th. I have just this information that today is 16. I want to see all the events on today.
So
How
that'll be
will
the
I?
second day, right?
So how will I know that what should be my from date in select query? No, there is no way to know about it, right?
Okay.
Because there can be some event which is going on back for month as well,
Yeah.
right? So I cannot. And if I go for between, it's a very tedious query such that the performance will be very slow.
Hmm.
So everyone understood the question, and everyone is going ahead with the kind of discussion we are having. Venkat,
Yeah.
Jose, Anurag.
Yes, Dhaval.
So what do you think? Which kind of then changes should be made? Tell you, this was one of the discussion I had with Walmart when I got offer letter at that time. So low level design discussion will go like this only, and you have to give an answer in very few minutes. Otherwise, your design is wrong. That's it. So then you understand that, okay, this way design going is not the right way. Probably I have to think something else. So we are going ahead with this, that what will be the query and its performance for a specific dates query, which we discussed, right? And we saw that the performance will be very low for such kind of table. So obviously we need to think of some other table. Think about what kind of DB design again you will create. Any idea?
Can you have like days of the month table, like all the whole year days table, and no, forget it, that's too
So
much.
obviously the whole year table is in calendar.
Yeah. Oh,
So
can you associate each day with the same event ID again and again? So you have a day table.
exactly,
Yeah.
not exactly as day table, but when I'm creating an event,
Mm-hmm.
I'm storing it in this way. Let's say my start time and end time
Mm-hmm.
and a date. So on 15th, my event started from 11 p.m. and on 15 itself, it
Ah, yes.
ended on 12 p.m. and a next event is on 16 from 00 a.m. On
Okay.
16 only, its completing time is 2 a.m. So the
This
event
way.
I'm segregating into two parts
So each event will only be associated with a day.
with a
So
day,
one to one.
one to one. Will that be helpful for my previous discussion?
Yeah, it will be helpful, right?
It
Because
will be
you're
helpful.
just querying a date. It's the fastest way you can query.
Exactly. So if I want to see even now a calendar view of a week, I can just pass that for this many number of days, what are my events? Even if
Yeah.
the events are getting spilled over between weeks, it's fine. I'm just checking
Mhm.
my events for this day to this day. And in this way, if I'm segregating, it's fine. Now, how will I correlate these two events? Why? Because if the cancellation happens or something like that happens, the cancellation will be on this both. So now you understand you need to have a parent-child relationship. Like you have a parent event ID, which you create something like this. Its start time is 15, end date is 15, so 15 11 p.m. and end date is 16 2 p.m. And it has two child events, which is like on 15 11 p.m. to 12 p.m. and on 16 you have 00 a.m. to 2 p.m. 2 a.m. Got it? So in this way now you need to have a parent-child relationship in event table. So either your event can be a parent or your event can be a child. And if your event is a parent, you need to have a list of child event IDs,
Mm-hmm.
right? Obviously, list of child event IDs, again, as we saw, it can be with another table,
Yeah.
event and sorry, parent event and child event, like that. Or
Linking.
in the most NoSQL, you can have the list of JSON attributes like that. So that is perfectly fine. But now you understood that you need to have such kind of things. So see, from where we started and with just three tables, what a complex problem we solved. And in interview, if you stumble upon this kind of thing and if you wait 15-20 minutes and you cannot, you are rejected, obviously, because for 1 hour of interview, 15-20 minutes has just went on for discussing and finding out just three tables. You have just designed three tables. You haven't thought about, because it's a low level design, you haven't thought about sharding, you haven't thought about indexing, you haven't thought about anything else. Just three tables and 15-20 minutes have been gone, almost your 40% of your time in this the question of this. So when you create this, the guy will have an eye that in which way you are creating this, and directly he will ask the question that have you thought all this. So when you are thinking, when you are trying to create an answer, think always, as I said, think always twice. Will it suffice all the requirements which I have in my mind? So in your mind, all such kind of things should have, thought through. Your mind should have thought through all kind of cases. Okay, next we'll go, okay, parent-child relationship if we keep, probably I can have an easy, you know, things with this. Again, furthermore, you can have many tables, like for file, you can have file ID and all that things like file ID, password, descriptors, and so many things, descriptions, and so many things. Okay, Furthermore, you can have many things. Now, if I'm inviting 5 members and I want to see who all have accepted and who all have rejected, can I see from here, from this database design?
No,
No. What you'll do for that? Again, you need to add
another
something.
table,
Is you need to think about that for
RSVP
furthermore.
table.
Exactly. So now we saw that, okay, now we have some date like this, probably changed. Okay. Then we thought about, okay, how will I know about the events? Then you can have something like this event user, a combination table like that you were mentioning, user ID and event ID. If he
Yeah.
is not part of it, if he is rejecting, he should be removed from this, so
Or
that
you
I
can
can
have a flag
directly,
as well, right?
you can have a,
You can keep them, but you can have a flag like
yeah,
going or not going.
rejected, accepted
Yeah.
or
Is
rejected. So that
yeah,
kind
yeah.
of thing can be there into this soft delete, I would say.
Generally, you don't really delete stuff in like
Yeah.
production stuff.
So I
Yeah.
would say status,
Yeah.
right? Yeah.
Yeah.
You can have now a calendar, file, user, and event. Now, what about if the event is recurring event? Every Sunday I'm going for a cricket. I used to go like that. If I want to create an event, has it has such kind of thing can be incorporated in this? No. What you'll do for that?
What is a recurring event? So it
Every
recurs. So
Sunday.
you still have to define how long it is going to reoccur for, right?
Exactly.
Yeah. So basically the event entity or the table will have to change, and then instead of you would have to add another flag like it's recurring, and based on that you can query it that way. You don't have to change much. You just have to have a flag, right? I think.
Exactly.
Yeah.
Probably right now you think about it. Okay, I'll just have a recurring type and frequency.
Yeah, that's it.
And the first event will be parent event, and rest of the recurring event will be child event. Because if you cancel a recurring event and you say that for all frequency you want to cancel, you want to go for all cancellation, right? Or you can cancel one specific event as well. So your each event should be segregated, separate, different, but they all should be linked as well, right? So you need both the things. They should be linked, but they should be segregated as well. So you, with this kind of way, but with a parent-child relationship, it can be done. Now with a parent-child relationship, again, the issue will come, because over here, parent-child relationship, you are specifying for date, if it is segregating based upon the date. Over here, you want to use same parent-child event for a recurring event. That one event date is ABC, A event, and the next event is on whatever the date, and this event is B2. So parent-child relationship somewhere you are keeping as this. But again, this event can have two dates, as we saw. Like our go hard event itself, it was recurring for everyone. But for Rishi, each recurring event was splitted into two. Right. So
Yeah.
how that would have been handled? So again, you need to think some other parameter for this. So my point is, when you design, when you keep on designing, the person will keep on asking you the same kind of question. Have you thought about this? This is a simple scenario. Have you thought about this? It's also a single scenario. What you'll do for that? And if you come into frustration, probably you'll see that you are creating a single table which is very large rather than normalizing it. If you see that you are creating just one table which is event very large, such that you are not even normalizing it properly. So always take a break, think about it, do a normalization, keep on doing normalization like this, and keep on segregating. Probably for recurring event, you can have a segregated table instead of over here, right? The same way for parent-child relationship, obviously you have a separate table, but in that way, you can normalize whenever you are going ahead with the system design or the database design. Now, so far we have just thought about few things. You haven't thought about holidays. Can I mark the holidays or not? Probably there's small things, holidays and all that things that can be incorporated very easily into this. But now if you see with this 5 tables, or probably for recurring event and all that things, with 6 or 7 tables, your system design have answered almost all questions, that how to view calendar, how to view today's or a week's events, how to send an invite, how to reject or accept the invite, how to see which all people have accepted or rejected the event, and how can I set up a recurring event, um, anything else. So whatever you think new probably can have a further requirement into system design, and you need to change your DB design like that.
Regarding holidays, Dhaval, holiday, you won't need add anything to the event because it's just another event, right?
Yes, it's
Instead of
just another.
yeah, you
It's
don't need anything to that would be different. You can make, because it's just an event. You can make it recurring. You can make it multiple days. Yes.
yes.
Yeah.
So holiday probably will not come in event. Holiday will be a segregated table. If you choose that, if in which way I would create a holiday list of holidays as in a segregated table, because based upon the region wise and everything wise, the holiday table can be segregated or separate. Holiday list can be separate, and that holiday list can be part of your calendar.
Yeah, but that's another. I actually didn't get that because holiday is just an event. So if you want to create holidays in your event, doesn't matter when you want to create. It's just an event, right?
Yeah,
Why do
it's
you
just
need
an event.
another table for a holiday?
I'll tell you.
Okay.
Uh, if you're going for a SQL kind of a design,
Okay.
okay, do you need all this invitee, organizer, description file, start date, end date, parent, child, recurring? Probably recurrence will be there, but parent-child relationship and all that things in that holiday? No.
No, no, you don't.
So why to keep that? Instead of that, you can just have a holiday
But
that
that's
today
copying. That's creating like a subtype of event, right?
subtype of event. Yes, subtype of event. But if you're going for a SQL design, this will consume a less space,
Hmm.
very less space.
You have multiple event types now. So you have
Exactly.
normal event. You have
Multiple events.
like a
Yeah.
thin event, or something like that. Okay, fine, fine.
So as I say, we discussed very few things regarding the requirements, and we came up with such kind of system design. We haven't still so far gone with furthermore like sharding. Indexing, probably yes, indexing is normal thing that internally based upon the IDs and all that things, it can go for indexing and all. Okay.
How would you prepare for this kind of stuff? Because you
So
can discuss. You can discuss. It's easier when you discuss because it's more like brainstorming, right?
yes,
But
you need to brainstorm with yourself.
like oh, okay.
So how I prepared like the same. When very I think it was um, Flipkart only when YouTube was asked to me, and then it was Walmart for some other question. But before Walmart, when I used to take the system design round, I used to read some of the interesting discussions which are there into Career Cup. And then what I started doing, a few uh, things I read, and then I started thinking about this. Hey, what if I have to design an Uber? What if I have to design an Ola shuttle? You have Ola shuttle, right? Ola shuttle in the sense it's just like in your childhood days, you have the auto, right? That you have subscribed an auto. Your parents would have
Go to the
subscribed an
school.
auto for you, yeah, to go to the school and to bring you back, right? The same
Yeah, yeah.
thing, Ola shuttle can be there to take you to the office and to bring you back from the office at certain point, but not exactly at your home, but very nearest to your home, such that a nearest neighbor of yours also can come in the same point and you can go. It won't be the main road as in a bus stop, but it would be a nearest point such that you'll have to walk very few 100 meters or something like that. Got it? So such way Ola shuttle is working. So then I started thinking, if I have to design an Ola shuttle, how will I design? How will my database design will be? How will I normalize it? Then when I thought about it, how can I reuse the similar kind of thing for bus system? Because for bus system, you'll have routes, you have transport system, you have bus IDs, you have passenger IDs, you have in user also some of the passengers are as it is, some of the passengers have passes, you have what you can say, the driver, you have conductor, so many tables you guys need to think about, entities you need to think about, and their relationship. How will you normalize in terms of, let's say this bus should have taken this route only, but due to traffic it is taking another route, so in between passenger it cannot pick up, right? So for the event management as well, sorry, I won't say event management, but for monitoring purpose, if the bus takes another route, how will you take care of it? How will you monitor it? How will you keep the log of it? So let's say if I report that, okay, some of the bus conductor has taken extra rupees for me to go from here to here, how will I log that? How will I find it out? What would have happened on that day and why the charges were higher? Probably they might have taken separate route to go from A to B, and because of that the charges were higher rather than normal charges. So all that things I would have to consider in terms of design. So when I was free and I was preparing for it, all the normal system which you can see over here in real life scenario, I was thinking how could I have designed in terms of DB, and how could I have gone for the normalization. And trust me, the best way is to go for SQL kind of design only initially. Then you can change it for NoSQL as well. It's easy, right? As we discussed, instead of this, if you have stored the list, you may not need this table, so it's fine. But the point is, you initially think about the SQL kind of a design only, and whenever it is required, you change it to NoSQL kind of thing. But you need to have a normalized view in your mind. Make sense? So
Yeah.
I prepared like this. I thought about many systems. Now, what's the time? It's almost 12. No worries. What I'll give you guys as an assignment. So probably this Wednesday, if I would be free, we'll take the session, and that would be our last session. Okay. And if not, then on Saturday, we'll take our last session. So in next session, we'll take some design patterns. So just do read about all the design patterns and how it could have been coded, because in design patterns, we'll take 1 or 2 questions and we'll see in which way you need to think about it.
Class level diagrams.
Exactly. The diagrams.
man.
There can be
No,
any
man.
diagrams. So I have seen in my interviews that they ask you any kind of diagram, whichever the kind of diagram they are using in their team. So in one of the team in Amazon, so when I wanted to switch the team, they were majorly keeping only activity diagrams, that in between the APIs or in between the systems, which kind of flow will happen of the data. If the user is coming at this point, what system he will call for which data, then which system will be called for which data, that will create which event again that will be fired when such kind of thing will happen, then which event, or sorry, which systems will read that event and further processes. So that whole event based architecture they wanted to draw as in terms of activity diagram for one specific usage. Whenever the user is onboarded for selling something on Amazon, then whole many systems are there. Let's say he will say that, okay, I'm thinking about this 10 different systems that will come into place of this. Now think about the activities of this user. Got it? So just with the name of system, you need to think what they would be providing, what kind of APIs they would have, what kind of events they would have, and what kind of whole water flow model kind of a thing you will create, activity flow or things you will create, that okay, this user has, or this system has this all, this
Flow
system
chart.
has this all, and this event will call for this, it will get some data, then it will call this, it will got some data, then they would have fired some event, some other system would read from it, and probably they would return some data to here, and this they would. So that kind of an activity diagram was necessary into one team. Another team was needing only the class diagrams, that okay, which kind of classes you will create. That's it. Generally the classes and the objects, the kind of objects and the kind of classes, they are co associated with each other. If you see, you know about the object relationship model, right? ORM models. So generally what happened, real life classes and their associated tables would be joined, which would be joined in the sense the similar kind of tables would be there into DB, and the similar kind of classes would be there into your design.
Yeah, it's mapping, right? Object
Yeah, kind of a
relationship
mapping. Yeah.
mapping. Yeah.
So the similar kind of thing would be there. Obviously, extra classes will be there, but a normalized view will have similar classes. Okay. So you guys also need to little bit read about that, which kind of diagrams. We are not going to take the diagrams in our session, okay? Because it can be a huge discussion that in which way you can draw the diagrams. And there are many diagrams, UML diagrams, class diagrams. So if you know about which kind of classes you can create, which kind of pattern, so let's say one design pattern you are using in this kind of classes you need to create, then you know which kind of class diagram you can create. Now, if you know about the flow, that in this way I'll take in system design, then you can go for the system flow diagram or activity diagram as well. Right, so the diagram I'm not taking, but you guys need to prepare for that when you're going for the interview. Okay, they won't see that, okay, a user has to be a draw like this only, or one-to-many relationship should be with a star only. They don't mind it. Even if you go for like activity like this, or you know, in UML you have all the specification of this, that this is something else, this is a start point only, and this is a decision only. Decision can be like this only. They don't mind that you draw everything in a square or a circle or a diamond. They don't mind. It's just that that knowledge which you are pointing it out, that is this is a decision step, that should be well written, well articulated, even if you are not drawing in a UML boxes. So you don't have to mug up that if this is the step, this kind of structure should be. You don't have to do that, but it should be well articulated that this is the first step, next step is this, third step is again the design. If it is failing, I'll go back again here. That kind of things, you need to be prepared for that. Okay, in which way you'll do that? As I said, no need to go for perfectly UML diagrams like in college we used to have. No need for that, but you should know in which way you'll represent your design. Either for class in this way, for activity for this way, for UML for this way. Got it? Now we have seen, yeah, tell me.
Can we have this recordings as like complete YouTube playlist, whatever recordings up to now?
Yeah. I have created a playlist only of whole batch 13.
Okay, can you share the root link, whatever?
Yeah, sure. I think I have shared, but again I'll share it. No worries. Okay.
Okay, thank you.
Now, next session, you just guys need to read about design pattern, and then we'll see. Furthermore, I just want you guys to think about one thing only. Apart from all this reading, what I'm asking you guys to read about or think about is, if I want to design, I'm asking you guys to, as an assignment, if I want to design a rule engine, you know what is rule engine, right?
Like some kind of validation engine or something.
No,
if you want to do something before, check all the rules.
Exactly. Now I'll give you an example. What is the rule engine exactly? Now let's say I have a credit card system. If you are some user, platinum user, something like that, if you purchase on 5,000, you should get 5% discount. That is a rule that I'm creating. If you are some other user, if you purchase same 5,000, but you should get 10% discount on that. Reward points are 10% because you are platinum user. Let's say you are none of the type of user, but still you are a new user for me. To attract that, you should, that is your first, let's say first 10 orders, and you are any one of the user, either this or third type, you should get flat 25% discount on any first 5 orders. That kind of rule I'm creating. Are you getting my point? Such kind of different rules I'm creating. Now, how will you store all these rules such that How will you store all these rules such that whenever your system wants to apply this rule, your rule has to be evaluated, right? That who are you,
Yeah.
platinum user, what you are purchasing,
Yeah.
how much is your purchase final amount, and what rule you should apply. There can be something else as well, that if the rule 1 is applied, rule 2 cannot be applied. You have taken already 5% discount, you cannot go for 3% additional discount on rest of the items, something like that, right? Because there can be that rule number 1 is also applicable, rule number 2 is also applicable. So there can be another rules as well which are on top of the rules, that if rule 1 is applied, rule 2 cannot be applied. If rule 1 and rule 2 can be applied, rule 3 cannot be applied. There can be, right? We might be seeing that in Flipkart or Amazon, we are purchasing, we are getting 5% discount from Flipkart, 10% on credit card, and delivery charge is free. So 3 rules have been applied because you are prime user, let's say. So 3 rules have been applied: 5% from seller, 10% from credit card, and something from else. So how this thing will be kept into your rule engine system? Because over here all the rules are of separate system, but here it can be that all 3 rules are of one system only, can be, right, of your credit card only. So what my point is, if you are designing a rule engine, that means I want to store rules and I want to process rules. How will I design my rule engine such a way, not code but database design? How will I do that such a way I can process it very easily? Now think about SQL, think about NoSQL, think about transactions. Transaction will be a very major chunk into that. What will be the type of transaction will happen into that? What will be about the security? Think about all the aspects. Okay, and design your DB for SQL, NoSQL, anything. What will be the right way? What will be the wrong way? If you go for NoSQL, what is that you will be lagging? If you go for SQL, what is that you'll be lagging? If you go for combination, what tables will be in SQL and what information will be in NoSQL? I want all that answers. And trust me, this will be a very fun challenge for you guys. If you think it is very complex, and this was asked in many interviews in different ways. For someone, I have seen that they have been asked as a rule engine to evaluate a flight point system. For someone, it was like to evaluate a rule engine for some internal mechanism for user management system. For some people, I have seen that it has been asked as something else. But the essence of that is rule. How a specified rule can be evaluated, can be stored. And as I said, it can be a very complex system. Multiple rules, which rule can be applicable, rule on the rule. So many things can be there. Think about it. It's good to think about it, and let's discuss on that next time.